Hey guys, today we're going to talk about being able to multiply functions, alright? And the main thing you need to realize is that to multiply functions we use the distributive property. So our learning target for today is we'll be able to multiply functions, and a good essential question is how do I use the distributive property? Okay, so let's just dive right into multiplying functions, alright? Because I like examples. So our first question is that we have some function f of x is equal to 4x plus 8. And then we have some function g of x, which is equal to x plus 3. And it wants us to find f of x times g of x. Okay, so first off, here's f of x, 4x plus 8. So the first thing I'm going to do is I'm going to write 4x plus 8. Now this is when I'm going to put both functions in parentheses because I'm trying to show you that we're multiplying the two functions together. Alright, and so here's g of x because it says times g of x. So I'm just going to write x plus 3. So since I have these two parentheses next to each other, that means I know I'm multiplying them. Alright, now the way you use the distributive property when you're multiplying anything, anytime you're multiplying something from a parenthesis or just something outside a parenthesis to another parenthesis, everything from this parenthesis must multiply to everything in this parenthesis. Okay, so everything's got to multiply with everything. So that means this 4x needs to multiply with this x at some point in time. This 4x needs to multiply with this 3 at some point in time. This 8 needs to multiply with this x, and this 8 needs to multiply with this 3. Now, you'll have different teachers teach you different tricks and steps and methods, okay? Here's what I tell you to do. Start with term 1, which is 4x, okay? Start with the first term in the first parentheses, which is 4x. Multiply that to the first term. So 4x times 4x. This is whenever you're multiplying variables, the same variables such as x times x, we add the exponents. Now, we talked about in class about how if we just have x, we have an understood 1 here and here. Okay, so in other words, 4x times x becomes 4 x raised to the, and then you just simply add the exponents. So 1 plus 1 is 2. That only happens when you're multiplying variables, the same variable, okay? Not if you're adding, only if you're multiplying. So 4x times x got me 4x squared. Now I want to do 4x times 3. All right? Sometimes you'll see me draw arrows. So 4x to x, and now 4x to 3. And 4x times 3 is 12x. Now, something I notice people forget to put is this. I said 12x, so that's a plus because it's positive. So I'm going to say plus 12x. I don't just write 12x. I got to make sure I put that plus sign. All right? Now, do you notice how the 4x is multiplied to everything in the other parentheses? Okay. So that means now I can move on to the next term in the first parentheses, which is an 8. And it needs to multiply to the x. So 8 times x, well, that's a positive, so I'm going to write plus 8x. And then I do the 8 to the 3, and that's a positive 24. Okay, so now I've multiplied everything. So I've used the distributive property completely. Now I just need to add like terms, just what we did yesterday. All right, so look for any x squares. I have one right here. So this is 4x squared. Are there any other, listen very carefully, are there any other x squares other than this one? Well, that is just x, and that is just x. And this is 24. There's no x's involved at all. So that means there are no other like terms to 4x squared. So I'm going to write 4x squared plus 12x and 8x. They're both numbers with just x's. Alright, so since they both have x to the first power, because remember, it's understood 1, alright, if you don't see a power, we can understood 1, then I can add the x's together, and that gives me 20x plus 24. Is there anything else you can add together? Sorry, I didn't mean to hiccup there. Is there anything else you can add together? Nope, so I'm done. Because what was the question at hand? Find f of x times g of x. Okay, next problem. Okay, I encourage you to pause right now and try this problem on your own. So hopefully you're now unpausing this video and you have your answer down and you want to see if you're going to get the same thing. So f of x times g of x. Alright, so first we're going to do the same thing we did. Everything from this parentheses needs to multiply to everything in this parentheses. That means this 2x needs to multiply to both of these things. So I just start off doing that. I do first to first. So 2x times 3x squared. Well, the numbers multiply the same, so 2 times 3 is 6. Now, This is an understood x to the first. This is x squared. If you remember in our prior example, I said that when you're multiplying x's together, this only works when you're multiplying x's together or dividing x's, but we won't get into that today. When you're multiplying x's together, you add their exponents. So this becomes x raised to the third power, because 1 plus 2 is 3. Now I'm going to multiply the 2x to the negative 1, and that gives me a minus 2x, or a negative 2x, whichever way you want to write it. Now I go on to my next term, because I've done everything in the first term. I mean everything, the 2x to everything in the second parentheses. So now I'm going to take this 4, I'm going to multiply it to the first guy. So 4 times 3x squared, well 4 times 3 is 12. That's positive, so I'm going to write plus 12x squared. And then the 4 times the negative 1 is the negative 4. Okay, so now what I want to do is just what I did last time. I want to start off looking for x to the highest power and adding any like terms to it. So x to the highest power is 6x cubed. Look at this example. Are there any other x cubes? Some of you may be tempted just to look for other x's. That's not a like term. Remember, to be a like term, they have to have the same variables that have the same powers on those variables. All right? So 6x cubed, are there any other x cubes? No. So 6x cubed. Then I like to go down in order of the powers, so from x cubed to x squared. So are there any x squares? Yep, there's a 12x squared right here. Are there any other x squares? No, so I write 12x squared plus 12x squared because it was a positive. And then minus 2x, and then minus 4 because none of those are like terms. And there we go. All right, next problem. Again, I encourage you to pause and try this on your own. Just know that this just means f of x times g of x. All right, so hopefully unpausing and trying this problem, you have your answer down. F g of x, guys, simply means exactly what we've been doing. F of x times g of x, okay? That's all it means. All right, I added an extra parenthesis here just to represent f of x times g of x. We've been using a star. You could use a little dot to represent multiplication. It's not a big deal. All right, so we're saying f of x times g of x. So f of x is 3, and g of x is 5x minus 3. All right, now this time I don't have two parentheses. I just have a number outside the parentheses. It's still the distributive property. It's the distributive property we've been going over. This guy, which is the only thing out here, needs to multiply to both of these things. So we're going to say 3 times 5x, which is 15x, and 3 times negative 3, which is negative 9. And then we just look and see, are there any like terms here? No, there are not. So then this is as far as I can go. All right, next problem. Okay. So this one's a long one. It gives me f of x and it gives me g of x, and it says f of x times g of x. So here's f of x, 6x squared plus 3x plus 2 times x minus 7. All right, I know this seems harder, but guys, all it is longer. There's no new steps involved. We're going to do the same way. This first term needs to multiply to everything in this parentheses. This second term needs to multiply to everything in this parentheses. This third term needs to multiply to everything in this parentheses. So we're going to say 6x squared times x. Remember, when we're multiplying x's, we add their exponents. So this is a 2 here, this is a 1 here. Since I'm multiplying x times x, I'm going to get x raised to the, well, what is 2 plus 1? 3. So 6x cubed. I'm then going to do 6x squared times negative 7. Well, that's just going to mean there's no x here, which is fine. I can still multiply non-like terms. 6x squared times negative 7 is negative 42x squared. Okay, now the first term is multiplied to everything in this parentheses, so I can go to the next term. 3x times x. Well, the 3 is the only number there, so I'm just going to write it. And then x times x, I add the exponent, so it's x squared. And I do not forget to write my plus sign because it was a positive 3x squared. Now I'm going to multiply 3x squared times negative 7, and I'm going to get negative 21x. And then I'm going to multiply 2 times x, so I'm going to get plus 2x. And then I'm going to multiply 2 times negative 7, and I'm going to get negative 14. Now I'm done using the distributive property, and it's simply time to put like terms together. So I start off looking for the variable with the highest exponent. So I look across this thing and I say, okay, x cubed. That seems to be my variable with the highest exponent. Are there any other x cubes? No. So I first write down 6x cubed. Now I want to go down to x squared. Well, I have an x squared right here. I'm changing colors real fast. I have an x, yellow was a mistake. I have an x squared right here. And I have an x squared right here. So I can put these two together because their variables have the same variables with the same exponent amount. All right. So negative 42x squared plus 3x squared is minus 39x squared. You'll notice that the variable and the power do not change when you're adding or subtracting like terms. That only changes when you are multiplying or dividing variables. Okay? So I went x cubed, I went x squared. Now I'm going to be looking for just x's, or otherwise understood as x to the first power, which I have here and here. Let me change colors. Okay? Here and here. This looks like poop. Let's change it to a different color. We'll use red. All right, here and here. So negative 21x plus 2x is negative 19x. And then we have the last number, which is minus 14. And there we go. There are nothing else we can do, since all it asked us to do was to multiply the two functions. All right, last example. Sorry, I know this video is kind of dragging, but this is an easy one, but it's going to look hard, so I want to make sure I talk about it. Okay. It gives us gx, it gives us hx. Guys, the fact that we're using different, letters here for the functions doesn't matter. F of x, g of x, h of x, that doesn't matter, okay? It tells me that g of x is negative 3x and h of x is 3x. Find the value of g of 1 times h of 1. So it doesn't just want me to multiply this function to this function. What it wants me to first do is find g of 1. All right, well, what does g of 1 mean? Well, we know that g of x is equal to negative 3x. And it wants me to find g of 1, so it's simply saying input the the number 1 in for x. So g of 1 is negative 3. All right, now we do h of 1, because that's what it says, h of 1. H of 1, which is going to be equal to 3 times 1, and we get 3. I now know that g of 1 is negative 3, and h of 1 is 3, so now I'm just going to multiply those two together. So I get negative 3 times 3, which is negative 9. And that is my answer. So g of 1, which was negative 3, and h of 1 times 3 is negative 9. All right, as you finish taking notes, guys, I heavily suggest you pause at the end of this and you write yourself a summary over these notes. Take a moment and do some reflection before you move on to the assignment. All right, you really got to make sure you think through everything. All right, thanks, guys. Please let me know if you have any questions. Send me a reminder, send me an email, just let me know.